Okay, at this point in chapter 4, sections 1 through 6, we have worked with our trig functions over and over and over again. You guys just did an exam and a lab on it, where essentially the idea was I gave you an angle, and then from that angle you gave me a trig ratio, sine, cosine, tangent, whatever. Mathematically speaking, generally, once you can do something going forwards, you want to be able to do it going backwards. And that's what we're going to work on now. If you remember from 171, a lot of times you talk about inverse functions, where maybe you start with x and the function gets you y, and then you come up with an inverse function that starts with y and gets you x. I think a standard example that you usually learn in 171 is something like, if y equals x squared is one function, then your inverse function would be the square root of x, where the square, say, takes you from 3 to 9, the square root takes you from 9 back to 3. And that's kind of what we're going to look at now with our trig. We're going to look at inverse trig functions. We've done, say, y equals sine x. Now we're going to do y equals sine inverse of x. Just so we're clear, this is not a reciprocal function, y equals 1 over sine x because of the negative power. That means an inverse function. It's just the way we write it. You can say sine inverse, or you can also say arc sine. So we could say y equals sine inverse of x, or y equals arc sine x. They mean the same thing. You'll see both in your book for practice. But like I said, essentially before, I gave you an angle and you told me the trig ratio. The inverse function has to do the opposite, which means I give you the value of the ratio and you tell me the angle associated with it. So for the sake of argument, what are the possible values of sine we get? Well, let's see, sine goes from -1 and then maybe negative root 2 over 2, then we'll say 0, then root 2 over 2, then positive 1. Now go backwards. If I plug in -1, I get y equals sine inverse of -1. What angle gives me a sine inverse of -1? What angle gives me a sine equal to -1? Well, if we think about our unit circle, let's see, all of you have this memorized. There's my unit circle. What angle gives me a sine value of -1? Well, that's right down here. Sine is the y value, so it's that angle right there. What angle is that? Well, I suppose we could go forwards and get the angle 3 pi over 2. We could go backwards and get the angle -pi over 2. And you guys all know from your coterminal angles, I could come up with a whole lot more that would give the same value. But the problem is this is a function, and each x, you all know, can only give me one y. So how do I figure out which of those y values is actually the value of the sine inverse? And for this, we can actually use another trick. If we go back to the graph of the sine function, and again, I'm leaving this separate from when we graph the arc sine. If we graph the sine function, well, let's see, it kind of does that, and if we go backwards, it does that, and so on. You all know the graph. And if you remember from your 171, once you start talking about inverse functions, the only functions that have inverses are one-to-one functions. Or you might have said in 171, functions that pass a horizontal line test. A horizontal line can only touch the graph in one place, kind of like the vertical line test. But the problem is, this thing is a wave that continues forever. All of our trig functions are, which means a horizontal line is going to touch that a whole lot more than once. So again, hearkening back to 171, when that happened with, say, the parabola, that's not one-to-one because the parabola horizontal line touches it twice. We did what's called restrict our domain. For the parabola, you would restrict to the positives and just leave off the left half of the parabola. Same principle here. I can restrict my domain to make this thing one-to-one. And generally the way we do it is we say, well, let's see. That's 0. I want to include 0. All of this is fine. Once I get to the top of the sine wave, if I go back down, then I'll be repeating. The horizontal line test would fail. So I'm just going to leave all that off. That's not part of my wave anymore. But now I can actually go backwards and do negatives. None of those have been repeated yet, but once I get to the bottom of my wave, if I start going back up, the graph will fail the horizontal line test, so all of that's out. And I get rid of that. And now, essentially, that's my sine wave. As far as a one-to-one function, it'll pass the horizontal line test, so I can find an inverse of that. So now, well, if we want to graph it over here, let's see. Now the x's I plug in will be the value of the sine. The y's I get out will be the angle. But what angles is this actually defined on? Well, let's see. For my sine wave, I reach my maximum at pi over 2. And I reach my minimum over here at negative pi over 2. So there we go. For our angles, we'll have to restrict ourselves to negative pi over 2 to pi over 2. One thing I'll point out, yes, as far as coterminal angles go, negative pi over 2 is the same as 3 pi over 2. But 3 pi over 2 is, if we graphed it, 3 pi over 2 is over here. And that's not part of my one-to-one function, so I can't use 3 pi over 2. I have to use an angle between negative pi over 2 and pi over 2. So now, just see what I get. If x is negative 1, if my sine value is negative 1, what angle gives me a sine of negative 1? Well, that's right here, negative pi over 2. If x is negative root 2 over 2, what angle gives me a sine value of negative root 2 over 2? All of you know your unit circle, sine, negative, that'd be the fourth quadrant. Root 2 over 2 is pi over 4 for my reference angle. Again, I need the negative angle, so I'll use negative pi over 4. I can't use 7 pi over 4 because that's not right here in this range of x's. Or y's when we switch it over. 0. If sine is 0, what angle gives me a sine of 0? Well, 0. That one's easy enough. What angle gives me a sine of root 2 over 2? Pi over 4. What angle gives me a sine of 1? Pi over 2. Now we can just graph it. Plot our points. Let's see. When x is negative 1, y is negative root 2 over 2. We'll say it's right here. We'll call that negative 1. And if that's straight, we'll call that negative pi over 2. I'm sorry. When x is negative root 2 over 2, which is maybe right around here, y is negative pi over 4, which is like right there. And we'll just draw the dot right there. When x is 0, y is 0. That one's easy enough. When x is pi over 2, we'll say right here. Y is pi over 4 positive, which we'll say is right about there. And when x is 1, y is pi over 2. Let's see, make that as nice as possible, right about there. And now just connect the dots. I know that almost looks like a straight line, but essentially there is some concavity here. So it looks like that, and then like that. And that's the graph of sine inverse. As far as it goes, well, let's see. If you remember 171, functions and their inverses have this neat trick where you can compare the domains and the ranges. So let's see. I think the rule was from 171, if you have the domain of f and the range of f, if you're talking about the inverse, the domain of one function is the range of its inverse. That's how we write the inverse of f. And the range of the function is the domain of the inverse. So we can test that on this one. Let's see, what is the domain of the sine function? You can plug in any x you want to get a sine value, so the domain is negative infinity to infinity. the range of the sine function, the y values you get out of the sine, that goes from -1 to 1. Well, now let's go here. For my inverse function, the domain of sine inverse, the x's I can plug in. Clearly, I can plug in x's from -1 to 1. The range of the sine inverse function, that's the y's I get out. Well, they go from -π/2 to π/2. If we remember what we just said, if these are inverses, then the domain of the sine should equal the range of the sine inverse, and the range of the sine should be the domain of the sine inverse. Here, these are clearly the same, -1 to 1. Here, these are not. The domain of the sine is all real numbers. The range of the inverse is only -π/2 to π/2. This still works as far as the definition goes, because again, this, if I use the entire domain of sine x, gives me a function that's not 1 to 1, so it doesn't have an inverse. So essentially, for the purposes of this, I changed my domain to -π/2 to π/2, which is where sine is 1 to 1, and then that turns out to be the range here. So the rules actually do work correctly. The other way of thinking about this, and I will say this briefly and maybe come back to it, but it tended to confuse my students in my seated class, so I don't want to get into it too much and maybe confuse you guys. If you think about this from a unit circle perspective, if that's my unit circle, the only angles I have available for sine inverse are angles from -π/2 to π/2. Which means that's -π/2, that's π/2. So sine inverse is only defined on the right, in the first quadrant and the fourth quadrant. Which means, given any sine inverse value, you just have to figure out whether your angle is positive in the first quadrant or negative in the fourth quadrant, and then go from there. This video was already a little too long, so we kind of went in depth on this. So I'm going to stop here, make another video on the cosine inverse and work through the graph, and then look at a few problems so we can kind of see what's going on at greater length.